Hello all and welcome back. So in this video, let us now move forward and try to do the minimum cost path question. This time using the tabulation, that is the pure TP approach. Now this will be the first time you all will be attempting a question in 2D DP with this approach, the tabulation approach. So it is very important to understand that how exactly we form our solution here. Okay. Basic idea and the requirement, you should completely understand the recursion approach as well as the memoization approach. Okay, we have discussed them in length in the last couple of videos. Now in this video, once we discuss the tabulation approach, you will have a lots of idea that how exactly we are able to reach questions like these. And then moving forward, the practice question which we have given, you can do based on this understanding. Though solutions for those questions are given, it is very much expected that you understand them from scratch so that you can do the same in your overall, let's say, any particular interview. Okay, great everyone. So let us start then. Let me just draw out the matrix. We are given a matrix like this here. Now we discussed in the last video that how exactly this matrix will get filled, right? What are the different sub problems which we are facing? Let me draw it like this. So yeah, we saw that, for example, first we are on 2 2, it will make a call on its left, right? So if I just write down the rows and column as well, on the left the call is going to be on 2 comma 1. Okay, then this will make another call on the left, it's going to be 2 comma 0. Now in these kind of questions, because we have to do each and everything iteratively, there is no recursion, no as such base case or condition which you can apply. We have to see that what are the sub problems which can be solved without any dependency. Now if you remember, in the memoization approach, there were some problems which can be solved without dependency, and for some we have to make these calls, right? The idea again is same, just that it requires a great in-depth knowledge of recursion concepts or overall each and every concept which we have studied with respect to recursion, list, 2D list, and that is where most students face the problem. Now, from the starting in this course, we have made sure that we are discussing each and everything in complete depth. And the reason is that now all of them gets bind together and gets useful while we are doing these kind of questions. So pay attention everyone, what exactly we are going to do. We have to make sure that somehow we can fill in the values where no dependencies are there. Okay, great. So if we even follow our overall this particular question, then you can see that now it's going to make a call to 2 minus 1, which is here. But again, in in tabulation, we are not making these calls. Okay, we have to rather avoid making these calls and check that, hey, you should not be making any call or asking for the value there, because that would be a problem. That would just give you the answer which will be not present. Okay, great. So instead of this call, because we will not make it and we can take it plus infinity, we will now go on top. Okay, so next call will be somewhere on 0 comma, we have to just change the 1 minute, so we have to change the row, so 1 comma 0. Okay, now 1 comma 0 will again, this particular node will again make the call here, which will be, we have to just subtract 1 comma minus 1. Again, it will get minus plus infinity. We will see, either we will have a if condition to say that, okay, get plus infinity, or we will try to avoid this particular call or particular filling altogether. Now next is where the first value will get filled, and that actually will be going to your base case only. So we know that this is my base case. If I am starting from this 1 and I have to reach on this 1 as well, then the minimum cost, the answer is going to be 1 here. Okay. Once we have filled this particular value, okay, then I feel that we can fill other values as well. What are the other values? So pay attention. This overall node, this sub problem, it depends on these three problems, right? We know these two are not relevant. So just using this problem, we can fill this as well. Then we can fill this as well. Okay, great. Similarly, we can now do this problem because it will depend here. Not in this 1 second. Yeah, it will depend on this and this. Okay, we have the values of them. No value. 1 minute. So okay, it will depend here as well, right? So let us see what is the next one we can fill. When we have filled those values. Okay, so let us fill that only. The matrix was like this: 1 2 3 4 8 2 1 5 3 4 8 2 1 5 3. Great. Now let us talk about this 0 comma 1, this particular sub problem. It will depend on this, this and this. Okay, these are the three direction which we have took. Now other two are not relevant. So just basis on this particular problem, I can write down my answer, which is going to be 5. Okay. Similarly, here I can write down 6 because this particular sub problem will also be dependent on just the top node. Now, if you will see, the whole approach is to make sure that those sub problems, those overall cells which have their dependency fulfilled, let us just fill them. Okay. Now we will not be making the calls, right? No recursion is going to get used here, but the understanding is coming from recursion only. And that's why we, in the last video, we understood that how exactly the order in which these cells will get filled. Okay. After that, I believe this cell can get filled because it has dependencies here. Okay. And we can see these two are not the dependencies which I want. So you will be seeing one more thing, that we are filling our overall DP array in this way, right? DP matrix in this way. So once this gets filled, everyone, it is going to be 3. Then this particular sub problem can also be done because it has dependencies on these 3. The idea is that I should be filling in the cell, the sub problem, where I don't have any dependency. Just that is my idea, nothing else. Right, everyone? If you are able to do that, that is where you can just work on, because the answer is pretty straightforward. You don't have to worry about anything there. It is just that if you have done this thing, if you are able to handle each and every sub problem, then you have the answer. Just take the minimum and add your cost to it. So now this particular can get filled because this, right? And you will see that in our code as well, this is the order. Each and everything is going to get filled here, right? So once this gets filled, then it's going to make the call like this. Okay. This has been done already. So we will make the call above. And finally, this will start getting filled. And once we do this filling properly, once we are able to solve each and every sub problem, fill in the cell value, we will finally reach here where we can just return our answer. Okay. So great, everyone. Now let us see how exactly this will get filled. Here I know the minimum is this. This is the one. So for this cell, we have 3 dependencies. I can write 9 here. Okay. Similarly, I can write 10 here. Now all the dependencies of this sub problem is fixed. Okay. So here I can just directly write 6. Then out of these two, it is 5. 2 from here and minimum is 3 here. Okay. So I have to see these 3 one. And finally, here I can say that 8 is the answer because this 5, 9 and 10, 8 is 5 is the minimum and 3 is the cost. Okay. So pretty sure that you will be able to understand this. I will highly suggest to see this part again and repeat the process. We are just trying to fill in our DP matrix based on the cells or the sequence such that every sub problem or cell has its dependencies solved. We will start with a base case. On that base case, some things will be there which will be dependent on that, right? Once that is done, then we can work on other part as well. Just one thing I would like to show you here as well. So let me just copy this particular cell, particular diagram. So let us just copy this and paste it here. Okay. Or rather, bring it on here. I just want to show you that how this sub problem thing is getting done. Okay. And this approach will be a lot helpful in many questions as well. So pay attention, everyone. If you see, if I just get this particular part out of my matrix, then I can draw it like this. Okay. Similarly, the first column, I can get like this. Okay. Normally, in these type of questions, when you are applying tabulation, you will either be going like this, okay, or you will be going like this, dependent on what call you have made first. Okay. In this question, we made the left call first, and then it started going upwards. So this is how we are solving all the things. Okay. Now pay attention. Let's say I am just given this particular matrix. Okay, so my cost matrix, let's say, was would be just a 1D kind of a matrix. Then you will see one thing. I know the cost here, which is 1. Now this particular cell, it though will be dependent on 3 direction, 2 of them are not possible. So I can easily fill each and everything here. In a similar way, this particular cell, though it will depend on 3 values, okay, it will be depending on 3 values, the other 2 are not possible, so I can easily fill in this. And once I am able to fill these 2, because I know there are no dependencies, okay, I will repeat from start. If I get this whole row out, and if I get this whole row out independently, now why am I doing this? Because this approach you will be using a lot whenever you do a 2D kind of a question. I have to show you that these boundaries, okay, they have the least dependencies in terms of your overall matrix or a 2D question, because values are values are not possible here. Values are illegitimate here. Okay, so we will see that these values are not possible. These values are not possible here. Similarly, here these values are not possible. So just a single dependencies is there, which is your base case, right, everyone? And this implies that we can fill the boundary values easily. Once you have done that, then this particular value, let's say this one, it will depend on 3 values, which is this, this, and this. And you have fill in all those values, right, everyone? So here the understanding goes a little away from how recursion was going to do things. Here you have to do each and everything from using iteration. Okay. So great, everyone. Now let us try to write down the code, and I'm pretty sure that it will become a lot more clear. Just a caution that if you are understanding this for the first time, please see these videos at least 2-3 times. It took me a lot of time as well to understand that in depth. Same I am trying, because I was not able, no one explained me with this much depth. Same I am trying that you all are able to understand in the first go. And then when you do the questions, you will have a lots of practice. Okay, cool. So let us now do this, everyone. This is your tabulation approach, right? Doing this iteratively, getting away from recursion as well this time. So def min cost path memoization. Okay, let's say cost m, n, and dp. So this time let us send the dp instead. I can make dp here, which is going to be like this. We take it 0. The reason I think all of you know now that we have to add these things, right? So 0 is a safe option. Instead of memo, I will just pass dp here, and let us call the tabulation one. Okay, have we defined this? Yeah. So let me define this as tabulation. I'm just passing the dp from outside. You can even have it inside as well. That should be fine. I want to actually show you by printing that we will get the same answer. Okay, let us save this as well so we can compare it. Cool. So now what we have to do, everyone, once we have this thing, let us now try to code down the solution here. Let us have some extra space. So you just see the solution. Great. So yeah, pay attention now, everyone. First, I think we can fill in the base case. That is dp of 0, comma 0 equals cost of 0 and 0. Okay, pretty straightforward. I don't think we have to do anything here. Great. Now, what we have to do, pay attention. I can write a loop for I in range m plus 1 for j in range n plus 1. Okay, I have to do something. Great. If we want, we can just do this in this particular loop as well. I can just say that, hey, if my I, and let us take it row and column so that it is a lot more clear to you. Row is m, column is n. If row equals 0 and column equals 0, then we know what we have to do. dp of I, row and column equals cost of 0 comma 0. We could have written a comma 0 comma 0, or we could have written row and column as well, because both of them are 0. Great. Else, okay, else. First, let us try to get the cost of left. Okay. What will be the cost of left? We know that it will be, if I want to go left, if I want to, let us see here, if I want to go left, let's keep the row as it is, just decrement the column. Okay. Which means dp of I, j minus 1. Okay. That is fine. Everything, okay, let me make it row and column minus 1. Okay. So all is good here, no worries. But there is a problem. If rj is greater than 0, then only I can do that. Okay. By j I means, so we are moving through the column, right? So if our column is greater than 0, then only I can do that. Even if it is 0, then the problem is that it will become minus 1. Else, we can say that, okay, it is float of infinity. Okay, everyone, I hope this is clear. I will just explain it here as well, what I meant by this particular statement. So this is a shorthand if statement. Pretty sure you must have learned about that. Here, this is the value if the statement is done, else we return this value. If I am here and I want to get the left value, I will just go here, then I will go here. But if the j is, if the column, okay, if the column is not equal to 0, then when I do column minus 1, I will reach here, which I should not. Okay, great. So let us remove this. Similarly, constant of, cost of top. Now this is very much straightforward with your DP solution. So that's why I'm writing it like this. Row minus 1 and col. Same condition. If row is greater than 0, else float infinity. Okay. Pretty sure now most of you must have understood this. Diagonal equals dp of row minus 1, column minus 1. If this time we have two conditions, right? So if row greater than 0 and column greater than 0, else I have just changed my overall recursion into a iteration. Nothing else you have done. Once I have these three values, then I can say dp of I comma j equals cost of I comma j. Again, that cost we have to add plus minimum of cost diagonal, cost top, cost left. Okay. So let us try to dry run this and see how exactly our DP array will fill. So pay attention everyone. Let's say we have this particular as a DP array. Okay. I will be starting from row and column. Row 0, column 0. Okay. So this I can just directly write 1. Great. Now if you will see, row will remain the same and column will increase. Okay. So I am filling in this manner. I am overall filling here in this manner. If we would have done the opposite, where we would have, if you want to go in this manner, then we have to make sure that row changes in each and every loop. So we have to keep the loop inside. Great. So pay attention. First I fill in the 1 because row is 0, column is 0. Okay, great. Next, when I will come here, the value is row is equals to 0, column equals 1, because now the column value will start from 0 and go all the way till 2. Right, everyone? Because 2 is the n, 2 is the n, and 2 plus 1 is 3. So this, for this value, you will see one thing. We will not be getting these two values. No, they will be coming out to be plus infinity. Because this condition is false. Rho is not greater than 0. Rho is not greater than 0. But we will get the left value. And what is the left value? All of us can see in front of us. This is the left value, right, everyone? So by just setting our constraints, I am able to say that, okay, get these values. And we can now just directly do and fill in that value. So what was this? 2, right? So I can say that, okay, I get the minimum overall as minimum is 2. My value, minimum is 1. My value is 2. So please write 3 here. Similarly, next, this will get filled. We will just get the left value. Okay, great. Now when we move forward, okay, we will go to second row. For this, we will not get these values because this time column is 0. Okay, but top value we will be able to get because this time, let me just draw it again. 1 minute. Yeah. So for the second iteration, what we have to do, everyone? See, we have fill in 1, 3, and 6 here. This time, row is 1 and column is 0. Okay. We will not get the left, we will not get the diagonal. But this top is something which we will be getting. Top, I have a value, okay, which is 1. So I will get the minimum as 1 because this will be 1, infinity, infinity. Cost ij or cost row column, I will just add to it. It will get filling like this. Finally, we will fill our whole DP matrix and our answer will be kept here, which we have to return. Okay, so let me do this. Let me just show you that as well, everyone. We can just have it as row call, row call. Great. Now what we can do once this all is done, return dp of m and n. Great. So let us try to run this. It's giving us an error. Name dp is not defined. Okay. We have not passed dp from here. Okay, so it is saying minimum cost to reach 2,2 using recursion is 8. Everything is -1 because we should put in dp here. And see now, 136, 595, 610, 8. Exactly the same metrics, right? If you want to do it the other way around, the one we discussed, just let me just write it in comments here. If you want to do it another way around, and that is the reason I explained you that either we go in horizontal direction or vertical direction, just do it like this. For column in range, n plus 1. For row in range, m plus 1. When we will do this, we will be going in this manner because initially the column will remain the same, but rows will change. And majorly every logic will be the same. Okay. In many iterations, in many solutions, you will see one thing also getting done. So I will tell you what exactly this is. Pay attention. So first we set the base case. Okay. First we set the base case. After that, okay, as I told, we can fill in the boundary by using loop. Okay. So many places you will see this also written. I just want to make sure that you understand that as well. So we will say that, hey, for row in range, row is in range m plus 1, right? Let me fill in this particular row. Let me fill in for this particular row. Let me fill all the columns value. So I can do something like this. dp of row and column is 0. I can just say that whatever the cost is, cost of row, comma 0. Okay, the cost which I have plus dp. Okay, so see, on what will this particular value depend? On the dp of top of it, right? We know this particular thing. So this will become dp of row minus 1 and 0. So I'm just filling all the values for 0 and it should start from 1 because we have handled the base case. Again, I will be doing this in another question, so don't have to get confused. Just I want to make sure that you understand each and every solution because many times students understand from different places So they should be aware of each and every approach. And I think the approach which we have written is the cleanest one because it actually is using our understanding of DP, recursion, and memoization. Okay. So normally I like to write everything with conditions in a single loop because that is helpful in handling each and everything. If you make a error in filling in the boundary first, that is also going to be a problem. So it is better if we write this or if we fill this up based on the conditions. Okay, everyone. So yeah, I think that was the major solution for this. I'm pretty sure that for people doing it for the first time, you must have gotten 70% of it. Rest 30%, just try to see this once again, and I'm sure that it will be clear. We will be doing more questions. I will be making sure to add more solution videos to DP questions. So don't worry on that. Once you do at least 5-7 questions, then you will get hold of how exactly we do DP in two-dimensional. It's a little difficult. It's not easy. But provided we move in steps, the way we have discussed each and every approach, it will become a lot easy. Now, I have discussed every approach to make sure that you understand different implementations. Okay. If you don't do that, if you just remember one implementation, that is going to be a problem because many questions it can happen that you might have to use some other implementation. Okay, everyone. So with that, I'm pretty sure you must have understood this. Now, please make sure that you write the code for this as well at your end in the coding exercise given to you. It is again very important. Okay, please do that. You just refer to my code, you just see the video and then try to write it yourself and you will get a very good idea. Keep a pen and paper in front of you. It is very important to understand how exactly are you writing this code. Okay, everyone. So we will be now doing more questions. As of now, please make sure that the coding exercise which is given to you, you try them out once and we will be shortly updating the solutions to that.